This is what happens when a GPU upgrade goes wrong. One wrong move and you can end up with exposed traces, missing components, and graphic card that won't even boot. But what if I told you the story doesn't end in a disaster? Today, I'm going to take a damaged Asus Noctua RTX 3070, repair the mistakes, completely upgrade, and bring it back to life. Hi, my name is Fraser and welcome to GPU Solutions. Today we have an Asus Noctua RTX 3070 in for both repair and upgrades. The owner told me he tried to upgrade the GPU himself, but things didn't go quite as planned. So he sent it to me to fix the damage and finish the upgrade properly. Now this is a chunky GPU and it takes up 4 slots in any PC case. So along with this card, he also sent some memory modules he bought from AliExpress, which he had intended to use for the upgrade. So let's go ahead and disassemble this GPU and take a look inside. As you can see, the memory modules have already been removed. Let's take off the backplate and examine the PCB under the microscope. Right away, I noticed the pads are intact, but the solder mask has been scraped off in places. Some components have also been knocked off. To be fair, he did a decent job removing the memory but likely scraped off the mask while cleaning the pads. The pads aren't completely flat and leaving exposed traces like this can cause short circuits during installation. Let's clean the area with isopropyl alcohol for a clear view. As you can see, the pads look grey, which usually means either too little flux was used or too much heat was applied. I'll start by preheating the board to 120 degrees Celsius before cleaning the pads. With the board warmed up, I'll tin the pads with leaded solder to lower the melting point, then use solder wick to flatten them. Now that the pads are clean, I'll remove the leftover flux with isopropyl alcohol. And the one that I'm using is 99.9%. The pads are shiny again, but I see several exposed copper traces that need covering, plus some missing components. The missing capacitors you see here are 1.8 volt filter caps, which are not critical, but the missing resistors must be replaced. I'll apply UV mask to protect the exposed traces, cure it, and then install the missing components from a donor board. With those components replaced, I'll measure the resistance to confirm that there are no short circuits. And everything looks normal. It's now time to install the memory modules the user provided. I'll preheat the board again, apply flux to both the pads on the PCB as well as on the memory module, and then carefully align to make sure it's in place. Alignment doesn't have to be perfect. As long as each pad makes contact, the reflow process will pull them into place. Now that I've installed 3 modules, I'll repeat this process for the other modules as well. And then I'll wait for the board to cool down. With all the modules installed and the board cooled, it's now time to run Maths. Maths is a program that checks for memory errors and if there are any issues during installation or the pads are not making proper contact, Maths is going to fail. But over here, we have a pass, which indicates that everything is proper, all pads are making proper contact with the PCB. Next, I need to update the strap resistors so the BIOS recognizes the new configuration. These 3 resistors here are strap 2, strap 0 and strap 1 from top to bottom. For Samsung 2GB module, the correct setting is 110. Strap 2 should be high, strap 1 should be high and strap 0 should be low. Originally, with Samsung 1GB module, it was 000, so everything was low. So I'll move this 100K resistor from strap 2 and strap 1 to high position, connecting it to 1.8 volts. I'll give the board one final clean with isopropyl alcohol to remove all the leftover flux. Since there were no thermal pads on arrival, I'll install new ones. This card uses 2mm pads on both the memory as well as the MOSFET area. A fresh layer of thermal paste goes on the GPU core, and now we can assemble the card. With the GPU fully assembled, let's put it on my test bench. I'll boot it to Windows, wait for the drivers to install, and then I'll go into the NVIDIA control panel to change the setting to maximum performance. For stability and thermal checks, I ran Firmark and the temps were normal and the card stayed stable. Next, I ran superposition in 4K optimized and the score was 11,269. Then, I ran 3D Mark Nomad and Speedway and they also returned a healthy score. The repair and upgrade was successful. This Asus Noctua RTX 3070 is now running perfectly with its new memory. If you found this video helpful, don't forget to like and subscribe. If you'd like to support the work I do, consider becoming a channel member. Your support helps me make more of these videos. So thank you for watching and I'll see you in my next one. Bye for now. Cheers.